Okay, what's our situation now? Well, we have our blue line. We have our red line. Let's use the red marker to indicate that. And we're still in focus. That's good. We have our points of closest approach that we don't know yet, and a line here that's perpendicular to both of these, joining these 2 points. And we've just calculated the cross product of a vector parallel to this line and this line, and determined that that cross product is (13i) minus 6j plus 30k, and that's the mutual perpendicular. Say that's mutually perpendicular to both lines. Now we have 2 points that we've just calculated, 2, 3, negative 1 on the blue line, and 4, 1, 3 on the red line. Again, not drawing these to scale. And these are going to be our points P0 and Q0, so that our vector PQ, P0, Q0 runs from this point to this point. If we project this vector onto this vector, we're going to get this distance. So the projection onto 13i minus 6j plus 30k of the vector P0, Q0, and let's see what P0, Q0 is, so we can just write out the coordinates. Okay, P0, Q0 is the vector from here to here. The x displacement from 2 to 4 is 2, so that's 2i. From 3 to 1 is negative 2, so that's negative 2j. And from minus 1 to 3 is 4. So the P0, Q0 is the vector 2i minus 2j plus 4k. So now when we project this vector onto this vector, obtaining this distance, we'll be projecting the vector 2i minus 2j plus 4k. Now projecting this vector onto this, we get the dot product of 2i minus 2j plus 4k dotted with 13i minus 6j plus 30k, and we're going to divide by the magnitude of the vector onto which we're projecting. Again, essentially making this vector into a unit vector, and then taking the dot product with our P0, Q0 vector. And you should think about why that's the thing we need to do. Okay, well, the magnitude of this vector is found by the Pythagorean theorem. The dot product is easy enough. 2 times 13 is 26. Minus 2 times minus 6 is plus 12. And 4 times 30 is plus 120. Dividing that by the square root of what we get here. 30 squared is 900, 13 squared is 169, so that's 1069, and if we add 36, I think we get 1105. So that, adding these up, we get 38 and 120 is 158 over the square root of 1105. and that square root is between 30 and 35, a little closer to 35, so we're going to say maybe 33 divided into that. It's going to be a little less than 5. Let's just take a guess and say 4.8 or 4.9. Okay, that should be the distance between these two lines. Again, obtained by projecting a vector between any 2 points of these lines onto a vector that's perpendicular to both. The perpendicular was calculated by a cross product, and the two vectors that we used for the cross product were dictated by the equations of the lines, and everything should be consistent then with the pictures that we started from.